Okay, for your problem today, you guys were supposed to do problem number 3. You're supposed to score it. Some of you did it, some of you didn't. Some of you told me you did it, but you lied to me. Some of you have already checked out and aren't doing anything the rest of the year. In second hour, some people identified who the worst procrastinators in the class were. And I'm not going to say who it was. So, we all have something to be proud of, so. In the math classes. So. All right, here we go. Problem number 3. Consider a differential equation. Let y equal f of x be the particular solution when passes through 1, 0. Write the equation for the line tangent to graph f at point 1, 0. Use the tangent line to approximate f of 1.2. This was the easiest differential equations problem that I could find that involves separation variables among the AP stuff. So I'm trying to give you as straightforward a question as I can. Where do I start with A? Slope and a point on the line. Okay, what's my point on my line? 1, 0. How do I determine my slope? Use the derivative. So I will take e to the 0 So all I did is I used my function. I'm going to use my function, and I get that. What's e to the 0? Times. So my slope is -3. My point on my line is 1, 0. So I have y is equal to -3 times x minus 1, or y is equal to -3x plus 3. So now I have an equation for a line tangent. The next question is to approximate, as it says, approximate f of 1.2. How do I approximate f of 1.2? So f of 1.2 is approximately -3 times 1.2 plus 3, or -3.6 plus 3, which is -0.6. So f of 1.2 is approximately -0.6. Now B says, find the particular solution given it passes through 1, 0. So I have dy over dx is equal to e to the y times, what is it, 3x squared minus 6x. It passes through 1, 0. So let's see if we can do it. Separation variables. Make it happen. Oh. Times by dx. So dy is equal to e to the y. 3x squared minus 6x dx. Now what? Divide by e to the y. So 1 over e to the y dy is equal to 3x squared minus 6x dx. Or e to the negative y, correct? So when I do the integral and I take the antiderivative of e to the negative y, what do you get? Negative e to the negative y. The antiderivative of e to the x is e to the x. The antiderivative of e to the negative x is negative e to the negative x. What point would I like to use? 1, 0. So we have negative e to the 0 is equal to 1 minus 3 plus c. What is negative e to the 0? So I have c is 1. Therefore, I have this equation. Negative e to the negative y is equal to x cubed minus 3x squared plus 1. If I'm finding the particular solution, what am I solving for? How do I do it? negative y is equal to negative x cubed plus 3x squared minus 1. Negative y is equal to the natural log of the absolute value, negative x cubed plus 3x squared minus 1. Divide by negative, y is equal to negative natural log of negative x cubed plus 3x squared minus 1. Let's see what they gave us for results here. Here we are. Looks like 1 point for using 1, 0 and plugging in the 1 and the 0. Looks like 1 point for the equation for the line tangent. Looks like the approximation was worth 1. So that very first part, if you got all those right, that's 3 out of 9 right there. Now look at how easily you can gather points. If you just separate the variables, so the dy over ey or 1 over ey dy, and then the x over dx to the other side, that gives you a point just for doing that. Finding both antiderivatives, solving for the constant of integration gives you a point using the initial condition of 1, 0. Then obviously your final answer. They don't write the absolute value. They say this solution is valid for an interval containing this. I don't think you even have to write that. In fact, I don't think you even have to do the absolute value. But we did. You don't get points for doing mad texting, but you do get points for writing those pieces down. So good work. Okay, let's try the next one. We're going to at least get it set up, and you guys will have some work time when we get back. So let's try number 4. This one's a little bit more challenging. Made a mistake on this one. So I went at this one blindly last hour, not having done it before. And I got myself an 8 out of 9, so I made a small mistake. Okay? Happens to the best of us. Rate at which a baby bird gains weight is proportional to the difference of its adult weight and its current weight. So whatever that means. Okay? So in other words, suppose that the final weight of the bird is 100 grams. Okay? And suppose that its current weight is 2 grams. You divide that, you get 50, right? It's going to be growing rather quickly at that time in its life. Suppose that the final weight is 100 grams and it currently weighs 98 grams. Well, that's just 1.02 or something like that. So you can tell that it's not growing very quickly as it's reaching its maximum weight. Okay, so that's what that means. If B of t is the weight of the bird in grams at time t days after it's first weighed, then the derivative, this is a rate function, the rate of the weight is equal to 1 over 5 times 100 minus b. B being the weight, not the time. That's important in the problem. That's where I made my mistake. Let y equal b of t, and I knew I made the mistake. I didn't have the opportunity to just sit down and kind of look at it for a while. I needed to teach through it and got myself in trouble. Let y equal b of t be the solution. Initial condition 0, 20. So therefore we have 0, 20. Is the bird gaining weight faster when it weighs 40 grams or when it weighs 70 grams? Explain your answer and your reasoning. Weight, not time. Again, we're looking at its current weight, not the time. I'm looking at the rate at which it's gaining weight. Does this tell me the rate at which it's gaining weight? Yes, it does. So if I want to know the rate, what do I do with the 40 and the 70? Just plug them in. So for part A, I'm going to find the dB over dt at 40 and at 70. So 1/5 times 100 minus 40, and 1/5 times 100 minus 70. I get 60 divided by 5 is 12. So 12 grams per what? Per day. Here I get 30 divided by 5 is 5, or 6, excuse me. 6 grams per day. So when is it gaining weight faster? When it weighs 40. Does that make sense that it would be gaining weight faster when it weighs less? Yeah. Anybody have questions on that? All right, then we move to B. B says find this in terms of B and use this to explain why the graph of B cannot resemble the following graph. Let's think about what we're trying to find, okay? What does that mean? Second derivative in terms of B, not T. And that's important because let me show you an example here, okay? Suppose I have dy over dx is equal to 3x squared plus 6x. What would the second derivative be? Right? Let's change that. Suppose dy over dx was equal to 3y squared plus 6y. What's the second derivative? 6y prime plus 6y prime. And you would gather, this is y prime, right? So you would take that and plug it in there and plug it in there in order to get it in terms of y. So we have to understand what the problem is asking for, and that's what got me in trouble. I knew something was up, and I just didn't want to slow down and go through it. That's my own fault, and I made a mistake. Not really. The derivative with respect to time is 1 over 5 times 100 minus b. Or 1/5 times 100 is 20 minus 1/5 b. So the second derivative what's the derivative of 20? 0. What's the derivative of negative 1/5 b? What is b prime? It says to write the answer in terms of b, not b prime. So you could leave it like that, or you could write it as what's negative 1/5 of 20 plus right? Whoops, sorry. Okay, I'm going to do one more thing. Are you ready? I'm going to multiply this through by 5. When I multiply through by 5, it's lunch.